Okay, and we are live. Thanks everybody for joining us. Today we are talking about OpenStack and network functions virtualization, and we've got a great panel of folks here who are really involved in this space from the community. So let's start with a round of introductions. My name is Mark Voelker. I work with Cisco on our OpenStack team here, and NFV is one of the spaces that I touch. I'm also a core contributor to the Puppet StackForge community, and I've been working in the OpenStack space for about 3 years now. And also run the Triangle OpenStack meetup here in beautiful Research Triangle Park, North Carolina. Toby, you want to introduce yourself? I think we might have lost Toby there. Okay, let's skip on to Russell.
Sure. So my name is Russell Bryant. I work for Red Hat. I've been contributing to OpenStack for about 3 years now. I was the PD of the Nova project for 2 releases. I've also been on the OpenStack technical committee since that was formed 6 years ago. I've been working on NFV related features in OpenStack in the last 6 to 12 months. I helped launch the NFV subteam in the OpenStack community. And I'm here to help continue to move forward.
Okay, and Mark McLoughlin?
Yeah, my name is Mark McLoughlin, and I'm Technical Director for OpenStack at Red Hat. I guess I've been involved with open source for 12, 14 years now, something like that, working at Red Hat for 10 years. And kind of virtualization management area has been my interest for the last 5, 6 years, something like that. Working on OpenStack for the last 3 years or so, contributed to Nova and some other projects. I've been a member of the technical committee and the OpenStack Foundation board, and I guess I'm just here to help us figure out what NFV is all about.
Thanks. And Mark McClain?
My name's Mark McClain. I am Senior Principal Architect at Yahoo. I was previously PTL for Neutron and currently member of the OpenStack Technical Committee and Board of Directors.
Thanks. Ian? Ian, I think you're muted there, bud.
That works better, with apologies. So I'm Ian Wells. I work with Mark in the OpenStack group inside of Cisco, and I mainly use OpenStack for a living. I put it to good use in NFV and other areas. And I've been working with OpenStack for 2.5 years now, and with NFV for almost as long, in fact.
Okay, thanks. And Chris?
Hi, my name is Chris Wright, and I'm the Technical Director for SDN and NFV at Red Hat. I've been focused on those 2 areas for the last couple of years and have been working in the virtualization space for quite some time now. So I'm interested in how we can help move NFV requirements into the OpenStack project and take OpenStack as a platform to NFV customers.
Okay, thanks. And let's see, Toby, let's circle back to you. Can you hear us now, Toby?
Yes.
Great.
So I've been working on virtualization and cloud technology for quite a while, and then over the last 4 years been working with OpenStack to try to bring it into AT&T and to our workloads and try to use it for the workloads that we have to deliver. And lately that's taken a turn toward the NFV space. Many of the applications that we have in a telco are looking for mobility and for our cable operations, and also just core networking that we do are all looking to move this direction.
All right, thanks. All right, so we've got a few kind of starter questions, but this is an open forum today. So basically anything related to OpenStack and NFV is pretty much fair game. But let's maybe get started with kind of a level set for the audience here and kind of go over the basics of what NFV is. So Toby, I know you come at this from the point of view of somebody who's been implementing NFV in their network for a while now, and you gave a great keynote at the last OpenStack Summit about this. So you want to you want to kind of give us your definition of what NFV means for you?
Sure. So NFV, much like other acronyms in this space, is somewhat overloaded. But just to keep it simple, we talk about it as if it's layer 4 plus functions being virtualized. Now, there is some overlap, and then much of what I'll talk about is also related to layer 2 and layer 3 functions in the OSI model as well. So switching and routing is very much top of mind in this space. So that's where we get a little bit of confusion. But essentially, anything that runs on the network is fair game to be virtualized, and that's for telcos. Sometimes we have a lot of hubris this way, and we think of probably everybody else thinks of as applications fall into this category. So things like with mobility, things like the radio access network, the EPC, and the IMS core, these are all functions that actually look very much like web servers and databases, just using different protocols. And then the cable and the sort of television space, anything to do with the movement of content from our content providers to our customers is fair game in this area as well. So it's a bit overloaded in the way that we think of it, but essentially everything is falling into this desire to virtualize.
Thanks. So Chris, you're a technical director who's been doing this for a while at Red Hat. Anything to add to that kind of definition?
Well, I think Toby got the core of it right on. The basics that I like to repeat to draw attention to it directly is you have an industry that deploys networking gear as physical gear. The functionality that's in that physical gear is trapped in hardware, and the goal here is to move that from hardware to software, and then be able to schedule that across a compute grid or a cloud, and take the economy of scale that comes with using common server hardware, use the sort of web scale architectures to manage your and operate your workloads, and try to bring the telecommunications industry into a modern style data center. I think it's really a cool idea.
Cool. Anything else from anybody else?
Yeah, I guess just to add, like for me, I still feel like I'm on a journey understanding what NFV is all about, and that's because I come from a background where I have pretty good insights into what the enterprise data center looks like, but have zero visibility into what telco data centers looks like and the kind of specialized applications that run there. And I think it's great the way Toby and Chris have been trying to draw the parallels between what's going on with the telco data center and what we're familiar with in the kind of elastic cloud, Web 2.0 space. And so I think, I'm finding that very helpful, and hopefully we can pass that kind of understanding along to others.
Thanks, Mark. And I should point out that Mark has a really great blog if folks haven't seen that. So we'll try to get a link up to that here in a little bit. It has a real good perspective on his take on his journey into NFV. It also has a link, I think, to some video footage of Chris talking about NFV. Okay, so moving along here, now that we've kind of level set on what NFV is, we also know that OpenStack already has a set of network services that center mostly around Neutron. So Mark McClain, you're a past Neutron PTL. How does NFV kind of differ from the existing network services that we have in Neutron today? There's probably some overlap, but also some distinction there.
Yeah, so you're right. There is a little bit of overlap in terms of how we're orchestrating VMs, but when it comes to wiring, we have some different needs. Primarily, Neutron's always focused on a layer 3 model, and for some of the services, we have to look at how we're connecting at layer 2 and lower layers of the network, as well as how we can, is part of the transition, how we can incorporate both virtual and physical devices, and better make those two worlds cooperate. So primarily, they're not obstacles that we can't overcome. It's just that we haven't addressed them, mainly because we've been focusing on the enterprise use case for most of the time.
And Russell, you're a former Nova PTL. How does Nova get involved in all this? Isn't this a networking problem?
No, it's certainly not just a networking problem. Just the core of this is trying to take functions out of hardware and put them into software that typically means running them in a virtual machine. And so we've actually been seeing quite a few requirements around NFV come into the Nova project, and those are largely around making sure we have the highest performance possible, and then that the performance is very deterministic as well, which is not always the case with the way existing elastic clouds are deployed.
And Ian, I don't think we've heard from you yet. You and I chatted a little bit more about this in the past, and kind of come to the conclusion that a lot of the work that we have to do is actually probably on the Nova side of things.
Yeah, it varies a little. And perhaps it's important also to understand that while Neutron has some services in it, they're not really relevant to what we're trying to accomplish here. So Neutron offers you things like firewalls and load balancers, routers, and those things they're useful for reselling to customers. They're not useful when you're looking at many tens of gigs of traffic coming in from your customers that you're thinking of even passing through a data center. If you're passing stuff through the data center, I think the two things you have to focus on is absolutely deterministic performance, and some of these things are incredibly hard work from a CPU perspective, but also performance on the network side of things. It's interesting that network performance actually crosses the boundaries between network and compute. You're struggling to get packets across the network, but then actually the biggest problem turns out to be moving them into virtual machines and through virtual machines. And so the compute performance goes, the compute requirements go through the roof when you're trying to do significant amounts of traffic.
Cool, thanks. So we've kind of level set on what NFV is and talked a little bit about the distinction between some of the services we already have in OpenStack and what we're doing with NFV. Let's talk about use cases a little bit. So Toby, you're the prime example of a guy here who certainly has a use case for NFV. What are you guys actually trying to do?
So there's two different really big classes of workloads that we're dealing with. One, as I was saying before, it follows very much the IT pattern of application architecture, and it shares its problems as well, where it's essentially some type of front end or some type of protocol it's exposing, and then there's various types of databases or application type frameworks that are underlying it. So in that model, there is a typical pattern that we're going through of trying to convert the applications in the IT space from more of the pets model to the cattle model, and we're doing the same with this space as well, trying to convert things like any sort of thing in the mobility, any service in the mobility system that does SIP or voice over IP, those elements, converting them over to more of a horizontally scalable model is one type of workload. There's also the other type, which is routers and switches and elements of the service chain, firewalls, progress on making them virtualized over time. And we're essentially just trying to get them to work and perform, and as Russell was saying, deterministically perform for us in this space. So that's sort of the two classes of workloads that we're seeing.
Okay, and Mark McLoughlin, you talked a little about OpenStack on the enterprise side of the house. What use cases are you seeing?
On the enterprise side of the house, like I said, it's all the traditional applications, and it's again about that, trying to make that from these applications which were typically vertically scaled and managed very closely, to try and embrace the new kind of scale out, the horizontally scale out, fault tolerant model of kind of new web applications. It's really interesting teasing through each of the kind of application use cases and trying to figure out how that transition will happen. But I think we're also seeing in the enterprise, and also seeing it in the NFV space too, how when we think about the elastic cloud model and the kind of parameters or the constraints that applications have to work under, we have an opportunity here in OpenStack to evolve how we think about that. So last week, for example, Russell wrote a really interesting blog on how we might rethink our approach to application, our instance high availability, and how we could actually do a little bit better than, say, some of the public clouds do right now. So I'm really enjoying the way in OpenStack we're implementing this elastic cloud model that we're kind of familiar with from some of the leaders out there, but we're also kind of taking it a step further and evolving and help driving how people think about that model.
Thanks. So, and that's kind of interesting because when we think about OpenStack, most people think about cloud, right? And they don't necessarily think about NFV. But it's definitely a use case that we're seeing a lot more people gravitate toward. So, from that perspective, what is it about OpenStack that makes NFV such a great platform, or OpenStack such a great platform for NFV? Chris, how about you?
Sorry for the delay. So, if you go back to how we were describing NFV, it's a use case where we're taking hardware functions and moving them into software. One of the reasons that that's an important goal for the service providers is the hardware is expensive to procure, it's slow to deploy, and you need to do things like provision to peak capacity right up front for a new service that you want to roll out into your network. As you move this into software, and you can take advantage of the elastic nature of the cloud, and you can scale up and scale down based on actual use and needs. This is where something like OpenStack, some cloud platform, really becomes the key to moving that hardware functionality into software. So hopefully that at least started to answer your question. But I think that's the really key part, is we have a scalable, elastic infrastructure. We have the hardware underneath is common. It's a bunch of common server platforms that's not specialized. And these are the key tenets of moving things out of hardware into software.
Mark McClain, anything to add on the Neutron side?
No, Chris covered most of it. I think the other advantage of OpenStack, which helps, is just being an open platform and widely deployed, and having some of that background at least being proved out in enterprise, even though we still have some work to go for high availability. I think it's a step up from building a different platform from scratch, I think, which also is another advantage.
Actually, Mark, that's a really good point. The service providers are saying, and maybe Toby could speak more to this, the service providers are saying specifically that an open source platform is a key to their future success, where the historic model for creating interoperability and openness in their networks was through a standardization process, which is slow and not necessarily as efficient as just building the software and sharing a common platform.
Yeah, as Chris was suggesting, as telco, we recognize when we look able to execute quickly and make function fast, and also are not encumbered by all the IP issues that we have in general. Open source provides us a lot of benefits of bringing a community of folks together, not just from vendors or from the people who typically make the functions, but also from our competitors and others in this market who need the same thing. So there's a lot of, it's reducing a lot of redundancy and work effort, and then over time we don't really want to pay licensing for non-differentiated function. As you've seen for anything, whether it's mobile or database functions, going to become open source and model. So for us, we recognize that, and then it's not been an easy sell, but it's definitely something that is an important dynamic we're going to take advantage of.
Thanks, Toby. So thinking back to where we were a few years ago, I think everybody here has been working in the OpenStack space for a while now. And if I go back to a couple of years ago, it seems like we weren't really hearing much about NFV in OpenStack. Ian, I remember you and I working on a couple of projects a couple of years ago, and it seemed like at the time that was a pretty novel thing. And now we're hearing about OpenStack as an NFV platform all the time, all the way up to Toby's keynote at the last summit. So what do you think is kind of driving the new momentum in the community behind this? We now have an NFV subteam in Neutron. We have ONFV making appearances in keynotes. What's changed?
I think on the whole we've recognized that there's a community of people who are interested. Part of it was 2 years ago, almost exactly 2 years ago now, I think, the Etsy NFV group organized itself, and that was a coalition of roughly the same people, but from more the networking side of the house, trying to identify that how they would go about virtualizing network functions and what components would be needed in a system that would have to orchestrate and deliver virtualized network functions. And they've spent 2 years writing documents that describe the building blocks necessary for that component. And from there on, and really it was, again, about 6 months ago when Chris and Russell and I all got together along with what turned out to be a huge number of people at the OpenStack Summit to say, look, so if NFV is so interesting, and I think at that point everybody had identified that OpenStack solved a lot of the problems that, that were at the lowest level of the NFV stack, then didn't we ought to be doing something about it? Didn't we ought to be coming together? And yeah, it's really effectively discovering that there were a lot more people out there that were interested in the same things that we didn't really recognize perhaps in the outset of things.
Thanks. Chris, did you have something to add?
Yeah, there's another piece of the puzzle, which is, as Ian mentioned, NFV as a term is 2 years old. It took a while for the industry to define it for itself. What's changed in the last year or so is with the crispness of the definition has come a sense of actual interest and even in some cases urgency for the telcos, the operators, to take this from a concept on a piece of paper to things that they can put into their labs and do proofs of concept with and even do some trial rollouts. So we've gone from conception of an idea to deep definition of the idea to really a strong desire to make it real. So here we are in the make it real stage.
That's always a fun place to be. For those of you that are watching along with us, if you do have questions, we're going to try to answer those live as we go here. So just feel free to type your questions into the event page, and we'll try to answer those as we go. Okay, let's talk about what's coming up next. So obviously, OpenStack just cut a new release. A lot of new stuff in there. Any goodness that we should be looking out for in the NFV space? Maybe Mark or Russell, you want to start?
Sure. So I can mention a little bit of stuff. So we implemented several features in Juno related to to help support NFV use cases, and we've got some more of those lined up. For example, we added initial SR IOV support for network devices. That was both Neutron and Nova, but there's still some more work to do there to further improve it. We're also looking at doing CPU pinning or dedicated CPU support in Nova. That's kind of part of providing much deterministic performance for the VMs for NFV. And we're also looking at huge page support for VMs. That's also another requirement for many NFV use cases. So we've got several features lined up on the Nova side to help support that.
Yeah, and for me, on the compute side here, the features that Russell talked about, this is where I really started getting excited about NFV and OpenStack and really starting to understand what it's about. So Russell has talked about CPU pinning and NUMA awareness and vCPU topology and all that kind of stuff. Those requirements are driven by these applications being highly specialized and, as Ian mentioned earlier, wanting high performance but also deterministic performance. And so the idea here is you've got the specialized application. how do you run it in a way that gives you that deterministic performance? And so you pin it to a set number of physical CPUs. You make sure it stays within the same NUMA node. You control the virtual CPU topology available in the guest, and that's part of the building blocks for guaranteeing that performance. But one of the difficulties when we first saw those requirements was trying to understand how we can take those requirements. We know how the application wants to run, but how to express that in terms of the OpenStack API abstractions, where you're in Nova, for example, you're running a VM by saying, take this image and run it under this flavor. And so we needed to understand how to express these technical requirements in terms of how would you express them as image properties, or how would you express them as flavor or instance type properties. And that work has been fascinating to watch, and I think we've ended up in a really, really good place. And when the designs first started being fleshed out here, I was really excited at progress we've made, and it was really, you can see the path forward now, how this is all going to land and how it's all going to be really useful outside of even just NFV.
Yeah, so to give an example of what that kind of looks like, if we take the CPU pinning example, if you think about that, the first way you might think about it is you have a VM and you're gonna specifically say that you want the virtual CPUs pinned to these specific physical CPUs. But in this cloud infrastructure model, you're not really supposed to have that level of knowledge or detail, or even be able to specify that from the API side. So what we're doing in the design is you're just expressing what the application requirement is, to say that this application requires dedicated CPUs, and then OpenStack is this management layer, figures out the best way to honor that requirement, and goes and figures out the way to pin the CPUs to honor that. And that way we sort of honor the way that the APIs usually work.
And I'd like to add, for Juno from the Neutron side, primarily we didn't add too many NFV specific features during Juno. I expect during Kilo we will be considering a few with Unbalanced, with all the other items going on, mainly because I think the NFV team wanted to make sure that the underlying compute resources were solid before wiring everything up together.
Makes sense. So speaking of future releases, we talked a little bit about the stuff that just came out. What's coming next? What are the next big problems that we have to tackle?
I think for the networking side, we have to finally resolve the question. I'm sure Ian will like to hear this, of trunk ports. He's only been talking about this for 2 years now. So I think during Kilo, we'll have to come up with a logical solution that fits in with our model. And similarly, Nova had some challenges to make sure the API is coherent. Trunk ports present an interesting just API kind of theory problem, but some of the background discussions going on, I think we'll be able to solve it this cycle.
I think that trunk port issue is interesting from a number of perspectives. I mean, some of the software I've worked with has been it needs VLANs, and bizarrely, and it tends to be a feature of using Open vSwitch in your networking as you implement your OpenStack cluster. Then VLAN tag packets they're not important to application designers of simple web applications. They just want L3 connectivity, and they don't miss the functionality. But they are certainly interesting to anybody who's trying to do lower level networking things. And particularly, I think you have to understand that what we're doing at the moment is we're moving some of our relatively legacy software onto OpenStack. So there's a kind of adaptation that seems to have to happen there, where you're dealing with the way it expects to use a network that OpenStack has never implemented because it's never really been critical for applications. But the other thing about trunk ports is it actually takes the step from NFV to what OpenStack delivers for enterprise and cloud service provider customers, which is that an NFV function, a virtual network function, can be resold to customers. You can make yourself this enormous network function and then resell slices of it at reasonable cost to end users who simply want a firewall. They want a little bit of firewall. They have their own traffic. Their traffic is by itself not very big, but the collected traffic of all the customers of the cloud together is very big, and so economies of scale kick in. If you're trying to do tricks like that, then you need to somehow coalesce the traffic from a lot of networks in OpenStack to a small number of ports to network function VMs. And when you're doing that, then VLANs or a kind of trunking of some variety is needed to bring that massive array of incoming ports into just a handful of ports for your network function to act upon.
Cool. Anything else we should be looking out for in the next couple of releases, guys? What are the things that we haven't tackled yet?
The biggest problem that we have is needing IPv6 support, and that's having it completely solved for is essential. There's no, unlike enterprise data center workloads where we can kind of get away with natting and all that, for mobile services, it's not okay. We absolutely have to have IPv6 support. So that's making that whole is key.
So Toby, thanks for reminding me. I forgot to mention that IPv6 support is available in the Juno release.
I also want to plug a wiki page that we have on wiki.openstack.org. The NFV subteam in OpenStack has been maintaining this page, and it's got several things on it, including references to use cases. But one of the big things we do with that page is we track development efforts. So a list of all the related blueprints to NFV use cases across all the different OpenStack projects. And so the page on wiki.openstack.org is teams/NFV, and I'll also post it on the event page to make it a little easier to find. But there's a list of several specific features that we're looking to tackle, and hopefully some set of those in this next release.
So one thing that we haven't mentioned, but it is in that page tracking all the different things that we'll care about, is something that, like trunk ports, has come up over and over again over multiple design summits, and that is a generic way to do service insertion. Many of these services are network, part of the network topology, and how do you insert something into a network topology that provides a network service in a generic way? That's an issue that the Neutron infrastructure has struggled with over the last couple of years, and I think we've seen the same kinds of proposals year to year, and maybe this will help us clarify exactly what the key needs are and how to make forward progress.
Yeah, I think it's interesting. We seem to, some of these problems, and trunk ports are one, they're useful to OpenStack as an infrastructure, but they're not key to people who are using OpenStack to run their web apps or any other kind of application. And I think it's our job as an NFV community to actually communicate that not only is this a thing that's useful to us, but it's also a thing that's going to help them, that anyone who's just trying to do very general kind of cloud use cases. A lot of these things, and again, the CPU stuff would be a prime example of this. Having consistent performance is great for everybody. It's just it's simply more of a priority for us, and we'd like to fix some of these things because they tend out to be the itch that we have right now, but they will be a thing that everybody else will care about as time passes, I think.
Cool. Anybody else?
Yeah, I really like that talk about scratching an itch or whatever, because one of the real advantages of an open community like OpenStack is just the amount of kind of diverse use cases, the diverse kind of interests people have. And people are often quick to dismiss, it's all just a bunch of companies working together, but it's a whole bunch of companies bringing a lot of different use cases. So we talked about IPv6, for example, and absolutely everyone involved with OpenStack would think that IP is terribly important, but it's a relatively small number of the companies involved with OpenStack will actually fund that work, and it's the likes of the telco use cases that will actually really prioritize that, as opposed to thinking about it as something maybe we'll get to it in a few years' time. For the telco space, it's it's critically important now, and so I think it's as a result of the interests around NFV and the telcos being involved and their vendors being involved that we'll actually get to see that work done a lot more quickly.
So that's maybe a good time to parlay a little bit into talking about how to get people involved. I think we've got over 100 people joining us today on the Hangout. I'm sure at least a few of them probably want to find out more after we're done today. So we've posted some links to the NFV subteam wikis. How else can people get involved here?
Well, I mean, I think there's the low-hanging fruit, which is getting involved on the mailing list. NFV team will send some traffic out. Also, Design Summit. I've already seen organization for selecting a birds of a feather again. I don't know if that's been decided yet, but I think getting involved in this community, helping to shape what some of the use cases are. One of the biggest challenges we've faced, and I think what's been helped by the NFV community kind of coming together, is being able to distill down the use cases, so it makes it easier to explain why some of these features are needed for, what Mark touched on a little bit earlier, which is some of the companies are in the diversity of the OpenStack development base is having, sometimes you have to explain these use cases to different entities, which it's not their line of work, so they may not understand it, so their immediate reaction is, no. So getting that work and getting involved in that process is very essential. It's really a great opportunity now, especially with Kilo starting, because we will need people to help shepherd and push through and do the work to develop some of the new features.
Yeah, and even if you're not doing development, you can still get involved in the development process. Mark mentioned you can get on the mailing list. That's helpful, and of course, if you can make it to the OpenStack Summit in Paris, participating in various design summit sessions and things is very helpful. Another thing you can do is for every feature that we implement, there's a design or a spec written, and that goes up for review on the same system that we review code, and it's incredibly useful for people that are potential consumers of these features to get on and take a look at what's proposed to make sure that the design that's proposed by whoever's doing the development actually solves your use case. It's much better to get that kind of feedback that early in the process than later after code's been written. So I'd encourage you to try to jump in on some of the spec reviews and provide feedback there as well. That'd be very helpful.
Yeah, I think that's a great entry to developing in OpenStack, honestly. There's a lot of code in OpenStack. Actually, it's well written in my experience, and it does make it easy to understand, but it's so much easier to think in the abstract. I've got this problem, here's a solution, and so does this solution work? And you get an understanding into how OpenStack works just by reading the specs and by getting involved in the spec side of things. It's a good entry to doing OpenStack development work.
Great. So speaking of people coming together to talk about NFV, there's actually the new OPNFV project from the Linux Foundation that was just recently launched, I think about 2 weeks ago now. So Chris, I know you're on the board over there, and I know when the press releases came out, we had folks from the OpenStack Foundation offering supporting quotes and things. What's going on over there, and is there any kind of crossover between what we're doing at OpenStack and what's going on with OPNFV?
Yeah, so the OPNFV effort is slightly broader than OpenStack, and it's about all of the different components that would build up an NFV platform. OpenStack being a key component there, some other key components being Linux, KVM, Open vSwitch, a mechanism for accelerating switching like DPDK, a software-defined networking solution like Open Daylight. Taking all of those components, bringing them together, looking at what the gaps are for the NFV use case, and first, from the gap point of view, just that gap analysis, and then trying to identify actual developers that would take those gaps and move upstream to the relevant project and start closing those gaps. We kind of already started that on the OpenStack side with the OpenStack NFV subteam. That team and the relevant developers in the OPNFV group, if they aren't more or less the same people, then we're fundamentally doing something wrong. So I really expect a lot of collaboration between these two groups, and in many cases for it to be the same people. But again, OPNFV is somewhat broader in the sense that it's not just OpenStack.
Great, thanks. Okay, guys, a little bit of a free floor here. What haven't we kind of poked at today that you want to talk about?
Well, I'll start with that one. I think one thing I've seen repeatedly while working with OpenStack is, I think, again, it's the cloud-centric use cases mean that that mainly its idea of network traffic coming in and out always goes through a single network with being IPv4 centric. It tends to involve NAT. It tends to involve firewalling. And I think as we move on to both, in fact, IPv6 and NFV, then we're going to want to broaden that edge functionality to be more involved with bringing in perhaps tunnels from customers, especially in the service provider space. With IPv6, it needs a bit of a rethink, I think, as well, to address the problems that are solved. Well, the problems of address scarcity with v4 just don't exist in v6, or at least they don't have to exist in v6. If we get that dealt with, then on the edge, getting traffic into OpenStack, then our life will be a lot easier from an NFV perspective.
Anybody else?
Yeah, I would agree. I just want to echo, I agree with Ian. I think there's a lot of work to be done with what we're offering on the edge. I think that's some of the exciting stuff that we actually can work on over, this cycle and the next couple of cycles. That's the kind of that hard part of the maturation process is choosing what items you're going to work on at any given moment. And we've largely left the edge pretty simple. So I think that's definitely an opportunity for folks, even folks who are interested in getting involved, to do some work there as well.
That's great. And obviously, for those of us that I think all of us on the Hangout here are going to be in Paris today, and hopefully some of our folks from the audience will be there as well. Any particular sessions or things that folks should be watching out for?
There's a few sessions on NFV directly. There's one on OPNFV. We are putting together the BOF for the NFV subteam. So there's quite a few high-level sessions, and then some of these are features that we'll be discussing in various project-specific design sessions. So if you're there and you're interested in NFV, I think you'll find a lot of material.
Yeah, and then I'll be talking in two different sessions myself, and one of them should be interesting. We're going to try to demonstrate, myself and the folks at Ericsson will try to demonstrate an actual virtual network function on OpenStack.
Awesome. And one other thing to kind of chip in here, one of the sometimes actually criticisms of OpenStack is that there's so many ways to deploy OpenStack, that there's all different kinds of combinations of hardware and software and different architectural considerations, ways to split up the services. If people are looking at deploying OpenStack as an NFV platform, is there anything in particular that they would need to be worried about, either from the arrangement of services and how they deploy things, or even from the hardware perspective?
One of the things I've seen as a repeated problem at the moment, and one I think that we will address again in Neutron, is that the port-based security, the security groups within OpenStack, they're on by default, which is precisely what you want for a cloud platform. They're not disableable, which is absolutely fine for most cloud use cases. We've been looking at giving some more configurability over that, and I think that needs to happen before OpenStack is easy to use. The usual trick is just to turn it off in deployment. And going back to the VLAN-based use cases, if you do need to use VLANs for whatever reason, then you end up deploying, or I recommend you end up deploying with Linux Bridge rather than Open vSwitch, because that will quite happily pass VLAN tag packets, whereas Open vSwitch is using VLANs for its internal separation and tends to throw away anything that it doesn't like the tag on. And then beyond those two, I think MTU generally proves to be an issue. it's not something you tend to come across again when you're using layer 3, but if you've got even just full-size packets, 1500 byte packets, then depending on how you've implemented your networking in OpenStack, you lose some of that packet size to encapsulation headers. So if you're using GRE or VXLAN to move packets between virtual machines on different hosts, then you've lost a little bit of packet size to that. And you get some quite amazingly bad network performance if you're running at full-size packets under certain circumstances. So you can deploy with a larger MTU size on your infrastructure, or you can bear that in mind as you start running things within OpenStack. But it's something to keep in the back of your head when you're putting a deployment together.
Your question mark there, I guess, about best practices and stuff actually hits on a really interesting topic that I'm hoping, maybe the NFV space can lead the way on. Typically within OpenStack, there's a lot of collaboration upstream around the code and around the project, but what we've struggled with over the years is to get more collaboration between the deployers and operators of OpenStack clouds, sharing knowledge about the problems they've hit, the best practices, kind of reference architectures and all that kind of stuff. And we've seen great progress on that in recent OpenStack summits in terms of the operator summits, and people standing up and giving presentations and immensely useful information. I'd love to see that take a step further into actual some way we can actually more concretely collaborate on some of these things in a very technical sense. So one of the hopes we had for the OOO project was we would have a way of encoding a reference architecture in a document format, and people would be able to collaborate on those, and that would establish a best practice. Perhaps it might happen in the OPNFV space, perhaps it might happen in the OpenStack community, but some way of operators in the telco space to be able to come together and collaborate in a very concrete technical way on kind of best practices, I think would be absolutely amazing.
Yeah, I think in the OPNFV space, one of the things we discussed was consistent tested deployments. Again, the flexibility of OpenStack deployment is great for a lot of people. Everybody wants to try something slightly different. In terms of NFV right now, I think what we need is something that's the same for everybody, so that when people are saying, this is the performance I get, these are the problems I'm hitting, then we're all talking about the same thing. It's a problem if we're all on slightly different deployments, because what one person sees may be completely different to what somebody else sees. And one of the things we were suggesting in OPNFV was that deployment and integration testing, particularly since it's pulling multiple projects together, would probably be central to what we needed to do.
So that kind of parlays into a question we have about reliability, which is the kind of the 5 nines question. How do we get OpenStack to the point where it's a platform that can support sort of 5.9 availability for some of these virtualized services?
I think that comes from 2 key different angles. One is the platform itself, and luckily cloud applications do care that the platform is reasonably stable, so we see OpenStack deployments being deployed in a highly available way. So the core services are redundant, and services are designed to scale out so that a fault in the service doesn't take out the entire cloud. That's a key component to building the reliability for an individual function. Functions themselves, as they move from hardware to software, they need to change. They'll need to adapt to a cloud model, and they'll need to adapt to a scale-out model. Luckily, in some of these cases, the function's already written that way. They weren't always designed to scale up within a single piece of hardware, but scale out to multiple blades or something like that. So taking the best of breed from the platform and from deployment ideas in the applications themselves, I think, is what will help us deliver these high availability requirements.
And I think even in the cases where a function, a network function, may not have been updated to a newer scale-out architecture it's going to be better for a cloud infrastructure, I think there's still more that we can do in the OpenStack community to provide better HA for individual instances, and that's something that I've been thinking about a good bit. There's been several proposals over time about how we can do that in OpenStack, whether it should be in this project or that project and so forth. My latest proposal that I posted on my own blog, which I'll get posted on the event page here shortly, is to provide that functionality as a function of the supporting infrastructure of OpenStack, so software underneath OpenStack, and really it's software that many OpenStack deployments are already using. And I think we're actually much closer to being able to provide that kind of functionality for individual VMs in OpenStack than many think.
Yeah, I think I would say in the going to entirely the opposite end of the spectrum, in the completely abstract, we need to get people to understand how to do failure mode analysis on things that are running as cloud applications. So the question is, you know, if today, right, I'm going to be upgrading my OpenStack at some point in the future, if my API endpoint goes out for, you know, 10 seconds or 10 minutes, how is that going to affect the customer, and how likely is that going to affect the customer? How badly is that going to affect the customer? And if you can focus on that, then it becomes a lot more easy to determine what kind of functionality you need within OpenStack and within your application to address the worst failure cases. And it becomes a lot easier to focus on the really important ones rather than the ones that are not necessarily, you know, you look at this and you say, ah, well, I need, and a common one actually is live migration of virtual machines. Live migration of virtual machines is very useful, particularly if you're running enterprise level applications. It's also useful in NFV, but less so, because if you're passing a lot of traffic, it may be that you can't maintain your SLA at the same time as migrating a virtual machine. Yeah, we have to get people thinking in terms of the kind of failures that are going to cause them the most problems and how to determine what those failures are.
All right, well, we are getting to the top of the hour here, so let's go ahead and wrap it up. Quick roundtable before we go. Any final words from anybody? Chris, let's start with you.
Well, first off, thanks for listening. I think this is a great opportunity for OpenStack. I'm really excited about what we can do to solve a new industry's set of requirements on a platform that we all know and love. So thanks again for listening. And come join us, especially if you're in Paris, we'd love to talk to you.
Thanks, Chris. Ian?
Yeah, I mean, I hope we've made you as interested as we are in NFV, really. I think it's a new problem space, it's a new set of problems. I really enjoy the puzzle, I think is the way I would describe it, and I hope we've given you a taste of that over the course of the conversation.
Thanks, Ian. Mark McClain?
Yeah, thanks for listening, and you kind of echo Ian. It's really exciting times with some of the challenges and opportunities we have, and so you know, getting everybody involved. I'm pretty excited, and I hope that meet several of you all listening in Paris.
Mark McLaughlin?
Yeah, sure. Again, thanks for listening, and I have to say I've enjoyed the conversation myself and learned a bunch myself. Like Chris, I think this is just a really exciting opportunity for OpenStack, but also open source more generally. But you know, we haven't mentioned it here. It's also really, really exciting in terms of, you know, what this will enable the telcos to do, and how we'll kind of see the telco world evolve in terms of applications that make a real difference to our day-to-day lives.
Thanks, Mark. Russell?
Sure. So thank you all very much. I think NFV is fascinating, but I think it's great that we're looking at solving this using open source building blocks. I think it's a huge opportunity for all of these open source components, and of course the telcos too. And like Mark said, I'm excited to see what this allows as we go forward. So thanks again.
Thanks, Russell. And Toby?
Sure. So two things. One, being part of the telco, I mean, we can really use the help. There's obviously we have big company issues, and having the community sort of rally around the NFV space has been very helpful. So I want to thank this group of folks as well as the folks watching in their interest and their help. So that's certainly one thing. And then as Mark was suggesting, I think the possibilities from here are pretty exciting. I think you're going to see in 2015 a number of technologies show up. The evolution of PCI Express, the real all the new Trident chips, the technologies around x86 hardware are just going to get more performant and make it possible to for in this space. So I'm excited about the possibilities that we have, and then hopefully that translates into cost savings and more interesting functions that we provide.
All right, well, thank you all for taking your time out of your day to join us, and we'll see you next time.